about the use of wireless sensor networks in environment monitoring. This is actually a project that was supported by OCE, the Ministry of Natural Resources, and Lunaris Incorporation. We have actually started this project 3 years ago, and it ended just last month. Yeah, so conventional or classical environment monitoring techniques, they are actually very limited in the number of sensors. They are limited in terms of spatial sampling. If you have a given sensor or a given sensor deployment in a given environment, it's very difficult actually to put more sensors or increase your spatial sampling. Of course, the sensors and transmitters are connected through cables, which makes actually the use of these devices very difficult in harsh environments, in a forest, for example, or in a city for pollution monitoring, for example. They have centralized power and processing as well. So everything is centralized, which means that if there is any problem with the sensors or any problem with power, then the whole system cannot actually run. And also, it's very hard actually to change the sensors if there are locations, for example, after deployment. Okay, so the whole deployment site has to be thought of and has to be optimized right from the beginning. So the flexibility there is really very weak. Also, these classical monitoring techniques, they need site visits by technicians to adjust the sensors or to check the power. So it's really very consuming in terms of human resources. And of course, these are non-scalable, which means that once you deploy your system, you cannot actually upgrade it. You cannot actually add more sensors. It's really very difficult. So what we have proposed in this project is to use the wireless sensor network technology. I think some of the presentations have been made this morning about this, and here another aspect about it. So here I'm an engineer. I'm an electrical and computer engineer. My area of research is wireless communications. I'm not an environment expert. However, we talk with people in geography, in environmental sciences, and they help us providing advice and telling us what are the requirements from this technology. That's why we were able actually to build a system which fits with the requirements of the environmental experts. So what's a wireless sensor network is actually a network of nodes. These nodes actually they are application specific, which means that they are dedicated to undertake specific tasks. So the nodes are capable of sensing, so this is the main task for these nodes, and also they are capable of processing information and transmitting it, of course wirelessly. This is why and where the term wireless comes from. Here you have a very simple unit here that we have developed to track turtles, to track species at risk turtles. So it's composed of a GPS, so here it's a GPS antenna, and then you have all the processing inside, and this is the wireless transceiver antenna. So it's really very small. So how it works? It works on a hop-by-hop basis, which means that if you are sensing the environment, you have a number of nodes in your environment, and then each node will take measurements of data that you are trying to sense, and then it will transmit it actually on a hop-by-hop basis. Okay, so the last node here will transmit it to the neighboring node. That node will transmit it to its neighbor, and so on till it reaches the sync node. So the sync node is really very important because it is the one that really has more capabilities. It has more power available. It has also more processing, storage capabilities, etc. And then, of course, from the sync node, you can transmit your data through the Ethernet, through satellite, through cellular, So things become much more easy afterwards. Of course, we have many constraints. I will not detail them here. In particular, power consumption, because you want the system to be autonomous, so you don't want to recharge the batteries or change the batteries often. The system has to be scalable, which means that if you want to add a sensor or a device into the system, it should not create any problem to do that. The system has to be cheap, etc. So there are many design features that have to be taken into account. So this is Crossbow sensor. This is a company in the US that developed some of this, and this is just an example. Of course, it has many drawbacks, but just to show here what are the components of a given node. So it has a microcontroller, it has a radio transceiver, it has, of course, the sensors, sensing devices, a memory, and a power supply. The problem with this is that it's a node which is off the shelf, which means that it has not been designed and dedicated to a particular application like environment monitoring. And the problem with these devices is that if you take them off the shelf, it will not work. And many people here certainly have tried that, and it's not necessarily, has not been necessarily to designed to work in a difficult, weather like Canada, for example, winter, summer, the transmission range, even the sensing devices. For example, for this Crossbow device, the sensing devices are built in, which means that you cannot remove them, you cannot add sensors on top of that. So it's really very, very, very difficult actually to make it customized to your needs. And this is actually what motivated us in this project, which is to design a sensor network which is really dedicated to the challenges in environment monitoring in Canada. So these are the examples of sensors. You have here humidity and temperature sensor. So you can have, for the temperature, for example, humidity, you can have a sensor which is very cheap, very also it can be very accurate, or you can have also an expensive sensor as well. You have here a CO2 sensor, this is a pressure sensor, this is a photosynthetic active radiation sensor, PAR. So you can actually deploy these sensors in each of your nodes. This is a general diagram of the system. So you have a given environment to sense, so you deploy your sensors in that environment, your sensor nodes in that environment. So the sensors, they will collect data. Usually you have a relay, just to reduce actually the power consumption and increase the efficiency of the system. You can have a set of relays actually, which will actually collect the data and then transmit it wirelessly. So everything is wireless. The nodes, they communicate together, they can communicate also with the relays. The relays communicate with the sync node, so this is the sync node, which is the last node that will actually gather all the information and then send it wirelessly. So what we have developed at Queen's is a system which is really very flexible. If you are in a forest, in a remote forest, which is flexible, which is really a harsh environment, where you don't have, for example, cellular coverage, then you can use satellite. Okay, so we have a satellite interface. If you are in a city, for example, measuring the pollution levels in the city, then you can use cellular network. If you are monitoring a building, for example, then you can simply use the Ethernet directly, and the sync node will be connected directly to the Ethernet through an Ethernet cable. So it has a tremendous flexibility. Also, Wi-Fi, it's possible to use Wi-Fi as well. This is what we did at Queen's. Actually, for our initial tests, we used the Wi-Fi system at Queen's to test the system.